Hello everyone, let's take a look at LeetCode on 1851, minimum interval to include each query. It's the last question in the weekly contact, and it's also a hard question. But there are many solutions to this question. So let's take a look at very simple solution. And this is a problem description. I will skip this section. So if you haven't read this problem description, please take some time to get familiar with this question. Okay, so the basic idea is we can sort intervals by interval width in ascending order. For example, this is original intervals. After sorting, it will become this. Then for each interval, we just find the qualified queries, the queries within the range of this interval. For example, the first interval is 4, 4. So query 4 is within this range. Next interval is 2, 4. Then we have 2, 3. 4 is not included here since we have already consumed it here. So 1 is 1, 4, nothing. 1 is 3, 6, we have 5. Okay, so in order to speed it up, like for each interval, the naive idea is we just for loop all the queries and to find each query within this range, but it's too slow. So we can put queries in an ordered data structure. Then use binary search to find the ones that first qualified. For example, we can use low bound to find 2 in the order set. Okay, let's take a look at implementation. First, we sort intervals. Next, we just push our queries into a set. We also push the index here, since it will use when we build our answer. Okay, this is our answer. We just return answer, and in this for loop, we just for loop each interval. And for each interval, we try to find the qualified queries for that interval. Okay, it's simple to find the qualified queries for each interval. We just use low bound to find the first one. Then we just find all the elements after this first one that qualified until that we met the ones that not within the range. We can just stop, or we met the end. We just stop. Okay, note that we use erase here, since we need to remove this from set once we consume it, and this erase function will return the next iterator. So we don't need to auto increment it here. Okay, that's it. Let's take a look at the time complexity. This is a sorting algorithm, so it will take n log n. And here we need to push m elements into sets, so it will take m log m. And here we will for loop n time. And the low bound is log m, so it's n multiply log m. And here, erase, we will erase at most m times, so the time complexity is m log m. Okay, that's it. See you next time.